Hello guys and welcome to the channel. Today I'm going to give you some additional notes for your final exam in mathematical analysis that are so important in understanding limits. Okay, without losing any time, let's begin with the first one. We have the undefined form 1 to the power infinity. So to solve the limits when the form is 1 to the infinite power, we will use a ready-made formula that simplifies a lot of our work. The formula tells us that when the limit when x goes to x0 of the function of x all to the power of g of x, that is another function, that can be written as e to the power of the limit when x approaches x0 of function of x minus 1 times the g of x. Okay, let's see it in an example. We have the limit when x approaches 0 of 1 plus the tangent of x all to the power 1 over the sine of x. If you look at it, we have the form 1 to the infinite power, so we have to use the formula. That is equal to e to the power of the limit when x approaches 0 of 1 plus the tangent of x, because this is our f of x in this term, minus 1 times the 1 over the sine of x. 1 cancels out and we can write the tangent of x as the sine of x over the cosine of x. Here the sine of x cancels out and we end up with the e to the power the limit of x approaches 0 of 1 over the cosine of x, and we put the value of x equals 0 at the cosine, we'll have 1 over 1. And this is equal to e to the power 1, or simply e, or the Euler number. From the important limits, we know that the limit when x approaches 0 of 1 plus 1 over x all to the x power is equal to e. But this is also a form of 1 to the infinite power, and if you use the formula, the solution is the Euler number, or e. Okay, now let's see the second additional note. That is called the L'Hopital's rule. L'Hopital's rule says that if the limit when x approaches to some number c of the function of x over the g of x has the form infinity over infinity, or 0 over 0, or 0 times infinity, or infinity to the power 0, then the limit when x approaches c of function of x over g of x can be written as the limit when x approaches c of the derivative of the function of x over the first derivative of g of x. So let's see this in two exercises. The first exercise tells us that the limit when x approaches infinity of x squared over e to the x, this should be evaluated. Okay, since it is the form infinity over infinity, then we have to use the L'Hopital's rule. But we can repeat it more than once. The derivative of x squared is 2x, and the derivative of e to the x is e to the x. Then we have the limit when x approaches infinity, and we have to do again the L'Hopital's rule, and we end up with a limit when x approaches infinity of 2 over the e to the x. Now if we put the value of x is equal to infinity, and this formula here, 2 over e to the x, we have a constant over infinity, and that is equal to 0. Now let's see the second example. We have the limit when x approaches infinity of x to the power 1 over x. But here we have infinity to the power 0, and we use the L'Hopital's rule again. But we do not know how to derive such functions like x to the power 1 over x. One of the best methods is this. Write the y, the function within the limits. So we can write y is equal to the limit when x approaches infinity of x to the power 1 over x. Then we have to do the natural log of those sides, and we end up with the natural log of y is equal to the limit when x approaches infinity of the natural log of x to the power 1 over x. Then the natural log of y is equal to the limit when x approaches infinity of the ln of x over x. But this here is again a form infinity over infinity, and we have to do the first derivative again for both the numerator and the denominator. And we end up with the ln of y is equal to the limit when x approaches infinity. the derivative of ln of x is equal to 1 over x, and the derivative of x is equal to 1, so this is 1 over x. And that is equal to 0, because if you put the value of x is equal to infinity here, we end up with a constant over the infinity, and that is equal to 0. So you have the natural log of y is equal to 0, and the y is equal to e to the 0 power, and each number that is raised to the 0 power is equal to 1. Thank you guys, and see you in the next video.